Hey Tony, welcome. Today we're diving into the cumulative frequency table and curve. You can see the lesson plan on your screen now. We'll start with some hook sections, learn the core concepts, and then do some worked examples and quizzes together. To get started, look at section 1, the spread of numbers. Just think about numbers you encounter every day, like canteen prices or your class test scores. They aren't all the same, right? There's always a mixture, or a spread of numbers. Can you think of any other examples where you see a spread of numbers like that?
Maybe flight prices.
Exactly, Tony. Flight prices are a great example. They definitely vary a lot depending on where you're going and when you book. So that idea of numbers being different and spread out is what we mean by spread. Does that make sense? Ready to move on to the next part?
Yeah, go ahead.
Great. Now you should see a table comparing two classes, Class X and Class Y. Notice that they have the exact same average score. Both have a mean of 70. But in Class X, everyone got a 70, meaning they were super consistent. In Class Y, the scores were all over the place, from 30 to 100. Looking at those numbers, which class do you think was more consistent?
Probably class X because it's very close and they all get almost 70.
Exactly. Everyone scored consistently close to the average. That's why we need tools to describe the spread, not just the mean. Ready to meet two students with the same average?
Yeah. Go ahead, please.
All right, let's meet these two students, A and B. Their scores across different subjects are shown in the table. 15 seconds. Take a moment to calculate the mean for each student. What do you notice about their averages?
So the student A average is, I think, is almost 75, and student B also 75.
You got it exactly. They both have a mean of 75. Good calculating. Now, even though their average is identical, look at their individual scores. Can you tell how their performance differs from subject to subject?
I think student B, his lowest is 60 and then highest is 90. The range is quite different than student A. Student A is almost 70 to 80.
Spot on, Tony. Student B's scores range from 60 to 90, while student A's are clustered between 70 and 80. So even though their overall average is the same, student B has a much wider spread of results. Does that make sense? Ready
Yeah.
to see a chart that makes this difference even clearer?
Yeah, go ahead.
Great. So, like you spotted, student A's scores are tightly clustered around 70 to 80, but student B's range from 60 to 90, much wider. This shows that the mean can sometimes hide the full story. Both average 75, but student B's results are much more spread out. So, just to make sure we have the key idea, which student would you say is more consistent in their performance?
Student A. Student A.
Exactly, Tony. Student A is more consistent because their scores are all close together. Now that we know why spread matters, ready to learn what the word cumulative means and how that applies to this?
Yeah, please, go ahead.
Okay, Tony, let's talk about what cumulative means. Think of a jar you drop coins into each day, like the one on your screen. As you can see, on Monday you drop in 3 coins, so the total is just 3. On Tuesday you add 5 more coins. What do you think the new total in the jar would be?
Sorry, say again. Tuesday it would be 8.
Exactly, it would be 8, because you're adding the 5 from Tuesday to the 3 that were already there from Monday. Now, if on Wednesday you add 2 more coins, what would the final total be?
10. It's 10. 8 plus 2. Yeah, please continue.
Spot on, Tony. Adding those 2 coins on Wednesday brings the total up to 10. So cumulative just means keeping a running total like that. Makes sense. Ready to see how we use this with data?
Yeah, go ahead. You can move to next section. I'm ready.
Great. Now you're looking at a standard frequency table showing the results for 40 students on a quiz marked out of 50. The score column splits the scores into groups. See how it used the less than or equal to symbol? That means a score of exactly 10 falls in the first group, between 0 and 10, while a score of exactly 30 would fall in the third group, between 20 and 30. Just from looking, which group do you think had the most students?
The score between 30 and 40.
Exactly, you got it. The table shows that 16 students had a score between 30 and 40, which is the highest frequency of all the groups. Make sense so far? Ready to continue to the next part, or should I explain anything else about this table?
Why there is a less than sign, but then on the right side is less than or equal sign?
That's a great question, Tony. The less than sign on the left, like 0 less than x, means the score has to be strictly greater than 0. The less than or equal to on the right, like x less than 10, it can be anything up to and including 10. Using equals on the right makes sure that if a student scores exactly 10, we know precisely which group to put them in, that first one. Does that clear things up?
What about if you put the other way? Less than or equal to 0 and less than 10.
You definitely could do that, Tony. In that case, a score of exactly 10 would be in the next group, the one that goes from 10 to 20, rather than the first group. Both ways are valid, but we just have to pick one rule and stick to it throughout the whole table. Standard math questions often do it like we have on screen, including the upper boundary. Ready to build the cumulative frequency table from this one?
Yeah, go ahead and build.
Perfect. Now we're building the cumulative frequency table, just like we did with the coin jar. We're just going to add up the frequencies as we go along. Take a look at the screen. For scores less than or equal to 10, the cumulative frequency is just 1. Now for scores less than or equal to 20, we add the next frequency, which was 4. Can you guess what the cumulative frequency for that row would be?
Sorry, which row? Sorry, which row?
Oh, I was just asking about the row for scores less than or equal to 20. We had 1 student in the first group and then 4 more in the next. So what do you think the cumulative frequency would be for that row?
It would be 5, and then 5 plus 17, 22. Sorry, 5 plus 12 is 22. Sorry, 5 plus 12 is 17, then 17 plus 16, 33. 33 plus 7 is 40.
That's exactly right, Tony. You've got the whole table calculated perfectly, hitting that 40 at the bottom, which is exactly what we needed. So now that we have our table, ready to see how we turn this into a curve graph?
Yeah, go ahead.
Great. Now you can see how we plot that curve. The score is on the x-axis and the cumulative frequency is on the y-axis. We plot points using the upper boundary of each class interval. For example, at a score of 30, we plot the point 3017. Why the upper boundary? Because the cumulative frequency tells us how many students scored up to and including that score. Finally, we join the points with a smooth S-shaped curve, not straight lines. The shape reflects how data clusters in the middle. Do you see how the curve starts slowly, gets steeper, and then flattens out?
Yeah, it looks smooth. So we should always connect it as a smooth line or straight line.
Always connect it with a smooth line like that S shape. Straight lines don't accurately reflect how the data naturally flows or clusters in the middle. Ready to learn how we actually read this graph now?
Is cumulative curve, is it always going to be like S curve, or it can come in a different shape?
It's usually an elongated S shape, Tony. That's because data tends to clump in the middle, making the curve get steeper in that section. While it might vary slightly from dataset to dataset, you wouldn't typically see a radically different shape unless the data was really weird. Does that make sense? Ready to move on to how to read the curve?
Yeah, go ahead.
Perfect. Now you're seeing the main technique for reading the curve, which is super important. Basically, whatever you want to find out, you always start from what you know, whether that's on the x-axis or the y-axis. Then you draw a line straight to the curve, and once you hit it, you turn 90 degrees to read the answer on the other axis. Start, curve, turn. It's as simple as that. Do you get the general idea?
Yeah. Can you tell an example using this graph?
Sure thing. You should see a worked example now. The question is, how many students scored 25 or lower? First, take a moment to read it through. Could you maybe try it on paper or in your head before I walk you through it?
Yeah, I see. I draw 25 to that graph, and then I draw a perpendicular on the left side, and yeah, it looks like 11 or 10.
Great start. You correctly went up from 25 on the x-axis to the curve and then turned left. Your reading of 10 or 11 is spot on. The important thing to remember, like you suggested, is that it's always an estimate. So we say approximately when we do that reading. We get about 11 students. Followed that so far? Ready for another worked example on reading the curve, but this time for something a little harder?
Yeah, go ahead. Yeah, you can move to the next section.
All right, Tony. This worked example is a bit trickier. The teacher wants to give a prize to the top 10% of students, and we want to know what score they need. This time, we're going in the opposite direction. Start from the y-axis, go to the curve, and read off the score on the x-axis. Pause and think about it. How would you find 10% of 40 students?
Yeah, it's 10% of 40 is 4. Then the 36 students scored at a below threshold. So I need to draw a line from 36 to upwards to the graph and then draw the line. Yeah. Yeah. Sorry, explain.
No problem. You nailed the main steps. Since 10% of 40 is 4, we need to find the score that 36 students or fewer got. You correctly said trace from y equals 36 to the curve and then down to the x-axis. Following that logic, the score needed is approximately 43 marks. Making sense? Want to try a quick quiz to see how you're doing with reading the graph?
Yeah, go ahead. Show me the quiz.
All right.
Okay. Let me upload the answer and then you check for me, okay?
Sounds like a plan. Take your time with the upload. I'll be ready to check it. No pressure. Got it. Let me analyze this for you.
So basically, I draw a line from 25 to 28 and then it meet the graph and then it end up like 14 and 10. So that means it's 4 students, 14 minus 10.
Precisely, Tony. That's exactly the right way to do it. You read the cumulative frequencies from the curve at both marks, and 14 minus 10 gives you 4 students. Excellent work, and great explanation. So that means the answer is C. Ready to see what's next, or did you have any questions about this?
You can move on next.
Excellent. Moving on to the lesson recap then.